Alright, here is my reassessment for Chapter 17, Section 17.1, 17.2, and here is my problem. Here we have three charged metal plates that are separated at two different distances and have tiny holes in them at locations A, B, C, D, F, and G. We're only given the distance of the first two and not the second two. We're going to solve the problem and get the distance of the second one. So here we have an electron traveling through each of the capacitors through these tiny holes from point A to point G, and all the way through its travel from A to G. It has a total loss of kinetic energy of negative 5.2 times 10 to the negative 18th, which we found right here. And we're also given the potential difference between these two capacitors, B and C, which is negative 16 volts. This says VC minus VA, but it's supposed to be VC minus VB. It's my mistake on my work. And the total amount of energy in the system has to equal 0 because of conservation of energy. So we can set up the equation of the change in kinetic energy plus change in potential energy equals 0. And to find the total potential energy, we have to find the potential energy of the first area plus the potential energy of the second area. And the potential energy of the first area is just simply the change of voltage, the potential difference of the first area, which is negative 16 volts, times the charge that passes through it. Since it's an electron, we know the charge, which is negative 1.6 times 10 to the negative 19th. And this is equal to 2.56 times 10 to the negative 18. And we can set the total change of potential energy equal to the negative change in kinetic energy. And the total potential energy is the potential energy of area 1 plus the area of 2 equals the negative change in kinetic energy. And so we plug everything in here, and we subtract 2.56 times 10 to the negative 18th joules from 5.2 times 10 to the negative 18. That's supposed to be an 18 here. I'll fix that. And so our change in potential energy of area 2 is 2.64 times 10 to the negative 18. And using that, we can find the potential difference of that area by dividing the potential energy of area 2 by the charge, and we'll get negative 16.5 volts. And then we can use that potential difference to find the distance of the capacitors, since we know electric field, which I didn't mention before, which is right here, using the potential difference of area 1, dividing that by the distance between the capacitors gives us electric field of negative 2,266.67 volts per meter. And since all the capacitors are the same, the electric field inside is the same for both areas. So we go back to finding the distance between the second area. We just divide the potential difference of the second area by electric field, which is negative 16.5 volts, divided by negative 2,666.67 volts meters, and we get the distance that we need to move to position the capacitors in order to get a loss of negative 5.2. A loss of 5.2 times 10 to the negative 18th joules of kinetic energy, and that distance is 0.0062 meters. And that is the solution to this problem.